Okay, so we are going to go ahead and do a sample balancing of an equation so that we can show you the process that we did in class as a reminder. So I'm going to put a line across the top of my board and a line across the bottom of my board so that I can have space to be able to write out my equations. The one we are going to start with right now is Al plus O2 going through a chemical reaction to give me Al2O3. Now, we know that there is an invisible one here, an invisible one here, and an invisible one here, telling me that I have one atom of aluminum plus one molecule of O2 going through a reaction to give me one molecule of Al2O3. Now, we know that you don't know how to draw these structures, but as long as you're drawing some kind of structural formula that you can see individual atoms on, you're going to be fine. Now, a structural formula of an atom is simply just the atom itself. It's not bonded to anything. One molecule of O2, as we know from class now, is going to look like this. A single bond is fine. Double bonding is good if you remember the octet rule. But for the sake of balancing equations, the bonding numbers do not matter. Al2O3 is going to look something like this, but again, it does not matter whether or not you know how to draw the exact structure. You could have even just put Al, Al, O, 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 as long as everything is drawn out in line like that. Now, the next steps that I'm going to do is start analyzing atoms on each side. And I'm going to stay calm and not panic when things start to go a little bit crazy. I'm just going to stick with my pattern. So I'm counting on the reactants side. So I'm even going to draw a little dot down right here so that I can see the difference between the reactants and the products. On the reactant side, I have one aluminum. On the product side, I have two. Where do I need more? I need them over here. I'm not going to create a molecule or anything. I'm simply going to draw another aluminum atom. So now I have two of them. So now I have two aluminums here and two aluminums here. Yay, everything is fine. Let's move on to oxygen. On the reactant side, I have two oxygens over here, but 1, 2, 3 over here. All right, where do I need more? I need them over here. I am not worried about math or having anything turn out perfectly yet. I'm simply going to draw more. So now on this side, I have 1, 2, 3, 4. And on the product side, I have 1, 2, 3. Where do I need more? I need them over here. So I'm going to draw another one of these molecules. I am not going to panic and start thinking, oh my goodness, something's going wrong. I'm simply going to draw the molecule again. Now I'm going to count again. On this side, I have 1, 2, 3, 4. And on this side, I have 1, 2, 3, 4, 5, 6. Where do I need more? I need them over here. I'm simply going to draw another molecule over here. Now I have 1, 2, 3, 4, 5, 6. And on this side, let's hope it's right. 1, 2, 3, 4, 5, 6. Yay, the oxygens are balanced. Am I done yet? No, I always have to go back and check the other atoms to make sure I haven't messed something up while fixing oxygen. So now I'm going to check aluminum. On this side, we had it right before at 2. So let's see, 1, 2. But now we have 1, 2, 3, 4. Where do I need more? Over here. So I'm simply going to add them again. Al, Al. Now let's do a last count. 1, 2, 3, 4. 1, 2, 3, 4. Yay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yay. It is now balanced. So now what I'm going to do is rewrite my equation at the bottom. Aluminum plus O2 giving me a reaction to form into a new molecule called Al2O3. And all I'm going to do now is count the molecules that I drew. I have 1, 2, 3, 4 molecules of aluminum. I have 1, 2, 3 molecules of O2. And I have 1, 2 molecules of Al2O3. And now if you are a mathematician, you can go back and check your work to see that indeed you have 4 aluminums. 2 times 2 is 4 aluminums. I have 3 times 2 is 6 oxygens. And I have 2 times 3 is 6 oxygens. This is a fully balanced equation. And now you are happy and move on to the next one. Yay! Goodbye.